Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about product recommendations. This topic is based on a tech blog with the title Building a Complementary Product Bundle Recommender, written by the data science team at CVS Health. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved.
What does CVS mean and what is their product recommendation?
CVS stands for Consumer Value Store, and the first CVS store opened in Lowell, Massachusetts in 1963. Nowadays, CVS Health is a leading healthcare and pharmacy company in the United States, with a market capitalization of approximately $70 billion as of November 2024. Beyond filling prescriptions, CVS also offers a broad array of products and services in health and wellness. It ranges from over-the-counter medicines to personal care items and everyday essentials. In their business, product recommendations play a key role in enhancing the online shopping experience, providing the convenience and helping customers finding relevant items. For instance, on CVS website, you will encounter sections like frequently bought together or customers also bought. These recommendations make it easier for customers to discover related products that they might need. For example, if you are shopping for cold medicine, the system might suggest tissues, hand sanitizers, or cough drops, those products that are commonly purchased together to streamline the shopping process and improve customer satisfaction.
So if they already have recommendations on the site, why do they need to create the new recommender?
Great question. Well, CVS does have recommendations. This new prototype addresses a different need by focusing on complementary product bundles. Traditional recommendations often present a long list of products, which can sometimes be overwhelming for the customers. This new feature, however, simplifies things by offering a smaller, carefully selected bundle where each item complements the others. For example, if you are shopping for travel essentials, instead of a long list, you might find a bundle called Travel Kit, which can include a neck pillow, travel adapter, and toiletries. Each item works well together. This makes the customers easier to make decisions and purchase everything they need in one step. Meanwhile, companies often either refine existing recommendation features to better match customer expectations or add new types of recommendations to address evolving customer needs. So both approaches are crucial levers that help drive sales and revenue growth. Now that we've understood the business problem to solve, let's dive into the technology side to see how the team leverage a few advanced machine learning technologies to achieve this. The technology behind this complementary product recommender prototype includes three main components. The first and most essential component is creating product embeddings. Embeddings are a key technique here. It transforms product text, like names or descriptions, into numerical vectors. This enabled machine learning models to capture the semantic relationship between words. For example, if you are looking at the cold medicine and the tissues, the embeddings of these two products would be very close together in the numerical space because they are often purchased together. On the other hand, cold medicine and sunscreen would be far apart, as they are not typically related in the context of a cold or flu. In this case, embeddings allow the model to understand how products relate to one another. To build these embeddings, the team used a graph neural network. Graph neural networks are effective for capturing complex relationships in graph-structured data, making them ideal for modeling interconnected products. The team aimed to create a product relationship graph to train this graph neural network. Typically, the product relation graphs are generated using co-viewership or co-purchase patterns, where items frequently bought in the past or viewed together in the past are treated as complementary and used to create the graph. However, CVS Health's team observed that the high level of noise in their user behavior data, as customers often shop for various purposes. For instance, the customers may buy cold medicines and snacks together, which doesn't necessarily mean that they are indeed complementary products. To address this, the team turned to generative AI. They used GPT-4 to identify the top 10 most complementary product segments for each item. To ensure the reliability of GPT-4's suggestions, the team developed a rigorous evaluation process, using metrics like precision at K to measure how well these AI-generated recommendations match human review complementary items. The results demonstrated strong performance, and it confirms that GPT-4 is very valuable to directly identify those product relationships. With this label data from GPT-4, the team employed a specialized graph neural network model called a graph attention network. To train this neural network, they designed a custom loss function that prioritizes product pairs based on factors like frequency or co-purchase, high sales volume, and reasonable pricing. This training process produced embeddings that support a non-personalized recommendation system, where the model finds the most similar products to a given item based on the cosine similarities from the embeddings generated. We talked about the first key component, embedding. The second component focuses on making recommendations even more personalized by creating user embeddings. The team did this by using each user's 10 most recent purchases products. And then they feed that information into the transformer model to produce a unique user vector. This user vector can be imagined as a combination of the most recent purchased vectors from the products. The third component of the system involves a re-ranking step that transforms the non-personalized recommendations into the personalized ones. First, the most similar items are identified using the cosine similarity based on the product embedding itself. Then, each of the product embedding is adjusted by multiplying it with the user's embedding to generate a re-ranking score. And this step makes the recommendation more tailored and relevant to each user. With this advanced product bundle recommendation system, CVS Health has the potential to apply this technology across various product lines. Although this recommender is still in the minimum viable product stage, it shows promising sign for boosting sales in both retail and pharmacy by helping customers discover complementary products. Additionally, the insights from the system provide valuable data for CVS analytics teams as well, and it enhances their marketing strategies and inventory management. Now we discussed both the business problem and the technical solution. let's wrap it up. In this episode, we introduced what CVS Health is and the importance of product recommendations for their business needs. We then delved into how their data science team leveraged advanced algorithms, including graph neural networks and generative AI models like GPT-4, to develop a prototype system. This innovative approach allows the company to build meaningful product relationships, optimize their recommendations, and create personalized shopping experience for their customers.
If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.